Let me create a new page to have, okay. So we want to go over sliding window pattern. Let me go here, sliding window, okay. Let's go in, let me bring some basic problem of this. Next session, we will go over sliding window and we will have really complicated problems of this pattern. But today I want to go over some basic problems to teach you the basic structure. And then I will go, next session, I will go over really complicated problems. Let's say we have, the question is, let me talk about the sliding window in general and when we need to do the sliding window. In lots of problems, we have an array, or let's say a list, linked list, vector, or a string, and we need to calculate. And the question is to calculate something, calculate something over all subarrays or subarrays. And subarrays can have fixed size or they can have dynamic size or variable. Let me write variable size. But the important point to detect the difference of which pattern you have to use, because it is really important. It is subarray. What does it mean, subarray or substring? It means a contiguous subset of any array list of a string. But we have another term which is subsequence. I want to differentiate these two terms because it is really easy to try to use a sliding window to solve a dynamic DP problem. When we have subsequence means, let's say I have an array. Let's say 1, 2, 3, 4, 5. Subarrays means all of the contiguous parts. So this is a subarray, and this is a subarray. Everyone knows that. But subsequence is any subset of this guy, and they shouldn't be necessarily adjacent. So for example, 1, 3, and 4 is a subsequence. These are subsequences. 1 and 5 is a subsequence. 2 and let's say 3 is also a subsequence. Subsequence is a general. Any is a general. Any subset is actually subarray or substring is a subsequence, but subsequence is more general term. So when we have subsequence, most cases we have to go to DP problems. But when we have some problems that we want to calculate something over all subarrays, and we have two different subarrays, fixed size subarrays or variable size, the sliding window pattern should be triggered, and you have to dive in using the sliding window pattern. But it is really easy to don't notice it is subarray, and we try to do the DP or recursive solutions. DP, when I'm talking about DP, usually you saw in the previous sessions, for DP problems, I go top-down approach. it means that I do first recursive and then convert this to memoization, and then I convert this to tabulation, which is the iterative solution. So if you have subsequence, go to the recursive solutions and give you problems. But if you have subarray, sliding window is the best. So let's go and solve the first problem. So we want to find maximum sum of subarray with size of k. With size k. First, I want to go with fixed size. And then the next session, we will go over variable size. And we will make it step by step, you know, really difficult problems. We have an array. Let's say we have an array of, let's say, the given is an array of integers. Okay. Let me make it, the assumptions are really positive integers. We have an array of positive integers, and we want to find maximum sum of all of the subarrays of size k. For example, let's go and do the 1, 5, 4, say 3, 2. We have this is our array, and let's say k is 3. How many subarrays with size k we have? This is one of the subarrays. So what is the sum of these guys? The sum of this is 1 plus 5 plus 4, 10. And this is another subarray with size of 3. What is the sum of this? It is 7 plus 5 is 12. And the last one, let me write in this way, 1, 5, 4, and 5, 4, 3, 4, 3, 2. So sum of this is 10. Sum of this is 12. Sum of this is 5 and 9. So we want to return the maximum. So what we should return? We should return 12. This is the question. This is, you know, the simplest question we can ask, you know, using the sliding window. So what is the brute force solution? I want to go the simplest one. Let's say I go and find these guys. I will find some of these guys, and then I will go find some of the second subarray and the other one, and then at the end I will find maximum of these guys. What will be the order? I need to traverse whole of this guy, right? And the traversing will be n, but for each window of k, which is 3 here, I need to do the k operations to find the maximum, right? I have to traverse all of these guys in the for loop and find the maximum. Actually, not maximum, sorry, find the sum of these guys. Sum of these guys. So it means that for each window, I need k time complexity to find the sum. And when I go forward, I can keep the maximum, update the maximum. At the end, I can return it. And this is the brute force, or actually the basic solution. When I say brute force, it means the most basic solution. But let's say, you know, I have here I have 1, 5, 4, 3, and 2. When I calculate the sum of these guys, which is 10, when I go to the next one, I don't need to calculate again all of the sum of all of these items. I can use the previous sum to calculate the sum of the new window. This is the general idea of the sliding window. Actually, the first solution also was a sliding window. We had a window and we did the sliding, but actually we didn't use the power of the sliding window pattern. We are doing this. Previous sum can help me to find the next one sum, right? When I go to the next one, let's say I have 10 for the previous one. I know that 1 will be outside of my window. So I will write 10 minus 1 plus the new one, the new item I just entered. So this is my sum of the new sliding window. It will be 9 plus 3 will be 12. In the same way, let's say I go to the next one, and the previous sliding window sum was 12. When I go forward, 12 will be minus 5. I know that the 5 is out of my sliding window. Minus 5 plus 2, which is the new value, will be 2, will be equal to 9. And I will keep the maximum value, and then I will return 12. As you can see, in this case, instead of doing the for loop to find sum of each window, we do only some scalar calculations. That's why we say the order will be order of n, because we only traverse once whole array. And for each sliding window, we do the calculations with order of constants. We don't need to do the for loop. And this is, the sliding window pattern basics. And now I want to go and write the code, and you will see how looks the structure. And I really recommend to follow the structures, because they will help you to solve really more difficult problems. But as you can see here, the sliding window is a fixed size, and we don't have lots of difficulties. But if we have variable size sliding window, which we will have the next session, I will go over that one. We have a little more challenges. We need to do some more extra calculations. So that's it, and let's go and write the code for this, because it is really small code. I want to use my I don't want to type it. I don't want to just write down my pen. So for window, as we said, we need 2 pointers, right? 2 indices to have window start. Also, we need another one. Let me write here. We need window start. I want to try to follow the conventions of namings in the Python, but I don't like it actually. They say you have to use underscore and then write the names, but I really like the conventions of Java. So we need window start and window end to implement our sliding window, to know what is my sliding window. So this is the one important part that you have to figure out before writing the code. So let's go and do all of we know the logic. I explained here. We want to implement this logic right now in writing the code. So let's say I want to define. Let's say max subarray sum. So max subarray sum. The name is really weird. So we have array and k as inputs. Okay. As I said, we need window start and window end, right? Window start initially is 0. And I usually start, do the for loop. We need a for loop, right? In the for loop, we need to move one of these, indices. Because window end should be always ahead of window starts, I prefer to write my for loop based on window end. And finally, I will detect that I have finished my, I have traversed whole array. We can go based on window start also, but I strongly recommend go and write your for loop based on window end, because you will see in the next session for shrinking your window, we want to go over, one by one, we will go with windows end forward. And sometimes we need to shrink our window by increasing the window start. Okay, so we have, window start, and I want to initiate my window end in the for loop. I don't need to do that here. Also, I need to return the maximum sum, which is my result, the maximum sum. Also, we need to have at every step the sum of each window. We need to keep this in one variable. So that's why I want to write window sum. Initially, both of them are 0. Okay, so window start, window end, we will handle this in the for loop. Max sum will be our results. Window sum will be our temporary, sum, window sum. So, and the next you will go and write the for loop for window end in range. We're going to go over whole array. The whole array is len of array. Okay, window end shouldn't go outside of the array. That's why we prefer to start with window end, the end of the window. So when we go, let's say window end is 0. I have to add this to the window sum, right? I want to update my metric. This is my metrics, right? I want to make this a little general here. So let's say the first step inside the for loop is updating the metric we need to solve the problem. Now window sum is our metric to calculate our, the output. And I will write window sum plus equal to array of window. So this part is updating metrics. But right now we have only one metric. Okay, so, and I will do this, and let's say the next round I will add this, and next round when I have to do some, calculations, when I have my window, when the size of window is k, or I can say that when window end is greater than or equal to k minus 1. Here, let's say k is 3, k minus 1 is 2. It means that whenever window end is equal to this or greater than this, it means that I have a valid window and I have to do some calculations. So we need an if statement to check if we have a valid window. So that's why I want to write here if window end is greater or equal to k minus 1, because when it goes after this guy, every time we will have a valid window. So this is the condition of having valid window. So condition of having a valid window. So when I have a valid window, I have to update my metric. So we updated here, right? But right now we have to update our result or answer. So how can I update this? I have to update my, right now I have a window sum. I have to update my max sum. So I will write here max sum will be equal to max of, because we want to keep the maximum sum. Max sum and the new window we have. What is the sum of the new window? We already calculated here, window sum, which is window sum. So I have the max sum. I updated my metric. Actually, I can say that, you know, we are update the result. We're updating the results because we have a window, we have to do some calculations, we do this. And now it's time to shrink our window, right? Always we do this. This is the general structure. We do the for loop, we check when we have a valid window, we update the result, and now it's time to shrink our, you know, our window. How we can shrink this? We want to increase window start, right? We want to increase this guy, but before increasing, we want to decrease window sum by 1, or, you know, the value in the window start. So that's why first I need to write window sum should be decreased by area of window start, because we want to shrink it. We need to update window sum, and then we have to shrink it by increasing by 1. So we shrink it, and the next round window end will go one more forward, will be here, and again it is greater than k minus 1. It is valid window. We will update the max sum, and we are shrinking our window. So let's say in this part also the shrinking the window. But before shrinking, as you can see, we have to update our metrics. And after all of these guys, we have to, in the same level of this, return max sum. Okay, that's the first problem. I didn't go over sliding window in previous meetups, and as you can see, it is really, yeah, sure.
Sorry. So shouldn't the last line in the for loop be Windows start +1?
Oh yeah. Thank you. It is, yeah. I said Windows start, but thanks for your comment. Okay, so because we want to shrink it, we have to increase Windows start, right? Yeah. Okay. As you can see, right now we have only one we traverse only once, and we don't do any for loop inside of this. So this will be order of n, and we don't use, this is our time in space. We don't use any extra space, and the space will be order of 1. But this is the general, structure. We have the structure is like this. We have a for loop over window end. For loop window end. First, we have to update some update the metrics, or all of the variables that helps us to calculate the output. I'm naming those guys as a metric. Updating the metrics, and we have to do, if it is a fixed size window, we need if a statement to if we have a valid window. If we have valid window, we do, again, we will do the first step, we will have update the metrics. Update the metrics, and then we will have shrinking part. This is the general, structure for a sliding window for fixed size. For fixed size sliding window. And you will see in the next session, if we have variable size, instead of if, we will have while loop here, because we want to do, maybe we want to shrink more than once. Here we have fixed size at every, for each increase, for each step we increase window end, we can shrink at most one step of our, the window, because it should be fixed size. But if you have variable size sliding windows, here, instead of writing if statement, we need while loop, because maybe we need to shrink more than once. And it is exactly kind of this structure, only we will have while loop here.